So we are continuing off where we left off yesterday. Yesterday we left off right with this particular screen. We created a lab time event. We tested adding, deleting, and loading. Loading again when we relaunched the app. So all the persistence models worked. Yesterday we also included a way to edit. So I'm able to edit, but currently my edit does not save. Right? So if I was to edit this and just say lab here and press return and update event, that does not change my update, right? So first step we'll go ahead and we'll go to the persistence class or the persistence helper class, and we'll go and add an update function there. Because two things we need to do. One, we need to persist the update in the documents directory, and we need to reload the table view because there's an update. Everybody with me? Okay, so those are the two things we'll do to make that update of lab time persist. So in our persistence helper class, our persistence takes care of all the CRUD functions, well, almost all the CRUD functions right now. When I say CRUD, I'm talking about create, read, update, and delete. Right, so we could create events, we could read events, meaning read it back from documents directory. We cannot update yet, but we can also delete. We can also delete, but currently we cannot update. Okay? So we'll go ahead and we'll update an event. So right where we have update here, we'll go ahead and create some update functions. Okay. We'll start off with a public accessor here, function update. We'll take the old item. Old item is of type event, and we have the new item coming in. So update old item with new item. Update old item with new item. So first we need to find out where is that old item. We need to get the index of the old item, because basically what we'll be doing is something similar to this. If you have an array here, you don't have to type this in, but if you have an array of stuff, what we want to do is replace some index, find the index and replace with some value. That's basically what we want to do. We want to find the index of that item, var. We want to find the index of that item and basically replace it. Everybody with me? Right? So find it, first find where the index is, then use that index and the new item, just put the new item into that spot. Everybody? Okay, so that's what we are trying to achieve. Okay. So let's go ahead and find this item. So I will call this variable index here, and we have items array. On items array, we'll say first index of some event. The event is the old item. I'll build my app. Right? So what does this first index do? It finds where this old item is. It returns the index. The index itself is an optional index, because maybe it does not exist. Okay? Maybe the item does not exist. So it's an optional. It returns an optional. And I thought one second. I want to show us one thing here. I thought I removed that, but let's go back here. If I was to build an app, go ahead, go to the event. Everybody, go to the event model and remove where it says and equatable, because we haven't explained what that does. So just make sure your event only conforms Make sure your event only conforms to quotable. Make sure your event only conforms to quotable. Yes? And go back to our update function, Command D, build the app, and we all should now have an error. Do we all have that error? Okay. What does the error say here? Let's explain it. So the error says argument type event does not conform to expected type equatable. Why it doesn't conform to expected type equatable? Right now we are trying to find some index, right? That index we're trying to find, what the first index does, it goes through each element, or it tries to go through each element and makes a comparison, like does this equal to this thing I'm looking for, right? Is A equal to B? Right? So it does a comparison, is A equal to B? Or is all item here, is all item equal to item being searched, or current item? Right? First index is it's a linear runtime. It goes through each element of the array, and it tries to see if the item that you're looking for, if it's currently in the array. Everybody? Right? But this is not going to work with our event currently, because our event currently, it needs to conform to equatable. It needs to conform to equatable. The item itself needs to say, hey, I am able to conform to equatable. Now you could say, you could search items in that event. If it doesn't conform to equatable, you cannot search using first index. Okay? Again, first index is a function that goes through each element in the array, searching for something. The way it searches for the thing, it makes a comparison between the two objects. Is Cassandra equal to Shania, right? If the two of them are equal, it returns the index of that particular item, okay? But in order for it to do that, the thing you're searching for, the elements in the array, needs to conform to equatable. Exactly, exactly. Equatable makes that item able to say equal, equal on it. Without saying equatable, I cannot do equal, equal on that particular item. Okay? Exactly. So, that's why we went back to event here. Let's go back to event. It's the same way like when we say conforming to quotable, like if you want to say JSON decoder on an object, the object needs to conform to quotable in order for it to be serializable into data. So the same thing we're saying with conform to quotable here, we have to say our event also conforms to equatable, right? And with the equatable definition, what do we see here? It says a type, meaning our event can now be compared for value equality, okay? At this point, if you build, the error should now go away. With your own custom type, like for example, when you're creating the photo journal, if you want to have that same logic there, you have to make your object, whatever you call it, journal, conform to equatable, right? If you do not do that, you can say, is object A equal to object B? Or is photo journal A equal to photo journal B, right? You need to conform to equatable. Very good. Okay, so that takes us back here. And at that point, we have an index. So if we have the index here, we'll write a utility function. I'll write one more function here for update. We'll put it down here. At some point, I might make that private, but it depends. Function is going to be update. And keep in mind, you could have function names the same, right? We've been doing that. We've seen that throughout iOS. We've seen that throughout Swift, where you could have a function name being the same. What differentiates that function to the next function is what? The arguments, right? The arguments in the function definition, that's what differentiates one function to the next, right? So here, the compiler doesn't complain, but if the functions match, same name, same arguments, then you have a compiler error, okay? So here we'll... The second is going to take, the second will actually take in the item and some some index, the index that we found from the first value. So the index we found here, we'll pass that index in, and it will do a simple replace.
Can you make it private, or does it have
We might make it private. It depends. Maybe the outside, maybe we want to keep it public if somebody just wants to pass in the index directly, right? Okay, cool. So we have an update here, and what does update take? Update takes in an item of type event, and it takes in some index, at index of some integer here. Okay, and we have our items array, and in our items array, we'll pass in the index, and we'll simply say item. So the item just gets replaced into that index, and at that point, we will save items to documents directory. And here we'll simply say do catch, try to save to documents directory. I need to update this. We'll just return some Boolean value. So here we'll just return false. And here we'll return true. It saves, when you call save items to documents directory, it has the items array in there, and it puts it back in documents directory. So if you look at save documents directory here, right, it has the same array. It has the items array. Right? We're always dealing with the same items array. It's private, so nobody else has access to it. Okay, so at this point we need to finish this function. Let's call update here, update, and pass in the new item, and pass in the index. And here we get results. We'll simply, again, return some Boolean value. Did the thing get updated? And here we'll just say return result. If not, we'll just say return false. The new item, we pass it. We'll pass the new item in our view controller. No. We'll do that. We started doing it yesterday, but we'll continue doing it today. We'll have both items. Let's introduce you to something new here. So here we have a return value. There's times where the user doesn't care about the return value. If you do not want the user explicitly to have like a let underscore equal, right? Like ignore your return value, you could use a compiler directive called discardable result. So discardable result, it's up to the user at this point to say, yes, I want to use the return value, or I do not want to use the return value. Okay? So what does that look like? Keyword at discardable result. Silence. That's good. Silences the warning if a variable or if the return value is not used. What's that? Come closer. There's a lot of space here. Silences the warning if the return value is not used by the caller. We'll see what that means when we use it. When we use it, we'll see what that really means.
You did that on both updates?
Yeah. Corona. Cool. Any questions so far? So we have two update functions. One takes in two items, an old item and a new item. It's very similar to our function in UI table view when we reordering a table view, right? When we reordering a table view, there's an old index and a new index where it does the ordering. This is very similar. Take the old item, take the new item. Why do we need the old item? Because we need to find out where the index is. Where is the index for that old item? We find the index for the old item, and we pass that index to our next update function that takes an index and some item. So the item is the new item. So we take the new item and we put it in that index. That's it.
So if we put the final result, that mean that we can take out return?
Not take out return, but you don't have to explicitly say let some variable equal to the return value. You could ignore it. If you don't want to use the return result, you don't have to. You won't get a compiler warning.
Then here we do what we do.
It's up to the user of the function.
So what would it look like if we were to have the startable result and not?
We'll see what that looks like in the view controller. When we use it, we'll see what that looks like. I'll comment it out and we'll see that we have a warning if we don't use it. And if we put discardable result, you won't have a warning. It silences the warning. Okay, so let's go back to our schedule list controller here. And we are going to, where are we here? Update all event, right here. Right at about line 78, I think all of us have the same code-ish, right? So right at line 78, in our update all event function, so when we have an event from our onWind segue, this function gets called by our onWind segue. It checks to see if the event is an existing event on line 66. If it's an existing event, that means it's an update, right? If it's an update, it comes in here, it calls our update function to go ahead and change that event. Update function calls our update here, and now we need to go ahead and use our update on our persistence helper. So we have our data persistence helper here. We call update. We have two updates, right? We're not calling the one of the index. If we had the index already, we're done, everybody? But we don't, I'm sorry. You mean the two updates here? It could be either or. Like if I have the index, for example, if I click on some index and I know the index, I could just use that index directly. But in our case, I want to separate it up because one takes in an index and one takes in two values. I don't want to put everything in one, because I might use one or the other later. Okay. So we're using all item here, and all item is, we need to get all item. The two functions are not doing the same thing. One function takes an index and an item and replaces the item at that index. The other function finds where the old item is. Okay? Yes, sir.
Can you go over why we create an instance of the persistence helper?
Of the data persistence helper? This guy here?
Yes.
So we use that here because later we need to have later we'll add in a custom delegate on the data persistence class. And a singleton won't work for us with that. Okay? Okay. Okay, let's go back to here.
So the example of that, we have index, that means we just adding new items?
If you have the index already, you just, first, if you have the index already and the item you want to do, you could just insert it into the,
And the second is you you're taking something out of it.
because right now here we have no index. Like if I say call index, I don't have the index. I have no idea which index it is. Correct? Like I can't call the one of the index value.
What
But if you have the index value, like for example, if you click on the cell and you have that index, like if we were to keep the index, we could just pass in the index. But here we don't have the index. So we have to find out where is that old item. Does that make sense?
Yeah, I'm just trying to understand the example of like, so for index, you're just placing new items
Yes.
somewhere.
Yes.
And the second one is you taking out.
It's finding let's go back to it here. Let's go back and explain it. So here, this one, it needs an old item because you need to find out where's the index. If you know where the index is, you could simply call this one directly.
In what case would we have an index?
You could do the code such that you know the index. Like if I click on, which I don't want to do, right? But you can. If I click on the row I want to edit, I could pass the index, yeah, and I could just say selected index in my view controller. But I don't want to do that. I don't think that's the best way to approach that problem, right? But if you were to have the index right there, you could just do it right there, right? If you saved it. Does that make sense? That's why I want to keep the two of them, because you might come to a use case where you have the index directly, whether it be you have it in a selected index variable in your controller or whatever it is there. Cool? Very good. Okay, any other questions before we move on? Between the two functions there. So function 1, all item, finds where the index is. Function 2 has the index already. It just replaces the item. Okay. So moving on to our update function here in our view controller. We call update, we have old event, we have new event, we have all that information already, that's awesome. So now we could just do data persistence, update all item. We have all item, it's all event. Luba, any questions? Please, ask them now. Any questions?
Yeah.
Yes, go ahead.
So, wait, so we're using, isn't this function that's private identical to the one in data persistence?
No, we need to reload our items here. It's not the same,
Okay.
right? It's not the same, they're doing different things. They're different classes, they're doing different things. The definition may look the same, but they're doing different things. This one calls the data persistence update, and it needs to reload the data for the view controller. We're in the view controller now. Okay, so last step, we need to call load items here. We have our load items. In the view controller, schedule list controller, right below our segue function, right below our new event will be added. And load items, if we recall load items, what does it do? Let's go to it. Load items basically queries the data persistence for its items, puts it into our array, and reloads the table view. Okay? That's all it does. Let's go back and make sure you have those two lines in our update. So first we have update documents directory, and basically retrieve the items and reload our table view. So let's put that in actually. So retrieve objects from documents directory, append to our events array, and lastly, reload the table view. Be careful, I've seen some people across, right, doing, in the did set, you call in like your load items sets your events calls your load items, right? So we have a cycle happening there. Let's be very careful with that, because it's very easy to get trapped there, but just observe what's happening. Every time you say did set something, and if you have a reload data, or if you have call my load items again, and on your events you have a did set, there'll be an infinite loop. Everybody sees that? So on our events, for example, here, we do not have a did set calling load items, okay? Really keep in mind, like, what's your intention? Like, what do you want to do? If you're coming from an API and you want to reload your data every time the events get set, you could have a did set here and say reload data, whatever, right? But anytime you say did set here, know that did set will get called every time you change, every time you manipulate the events, whether it be append, remove, anything you do, it will call that did set, and whatever in that did set block will get called, right? So be careful there.
So you're saying that we will be adding
Like if we have this,
is not good idea.
it's not a good idea. It's just be mindful of the code, what's happening in the code. So if here I say load items, for example, right? It calls load items when it gets set, correct? If I go down to my load items, what happens here? Events is set, and what happens? Calls did set, right? Everybody follow along? It calls did set, right? What does did set do?
So that you're saying that that's the issue.
I've seen it some places, right?
Okay, no,
And right, and then load items calls, right, events, and there's a cycle, infinite loop, and then your app crashes, and you're wondering, oh, what's happening? And if we saw recursion yesterday, if you take a look at the call stack on your left panel, you'll see like view controller dot load items like 40,000 times, right? So be careful like with what you exactly happening in your did set, because did set is very powerful. It's awesome, but just be careful like what code you put in there. Like, is it recalling? Is it like doing a recursive call on that event? All right, so this is good. Our update function is good. Let's go test it out and see what's not working and what's working. And please feel free, ask questions as much as we can here. So yesterday, what did we do? We said when we click on a cell, it presents the same create events controller, but it passes an event to that controller. That's why we have lab time and the exact time of the event. So here, if we change lab time to something else, like lab, I press return and update event. Lab, it reloaded the table view, but is that enough? Let's stop the app and see if it actually persists, right? So at this point, let's stop the app and let's see if lab actually persisted. It persisted, great, okay? What happened to date? Did we also do date? So today is Thursday, not. Today is today. And lab time, say it's 3. And we change that to lab photo journal. Just photo for now. Say update here. So it changed it. Did we also observe it changed the time as well? Let's see if it persisted the time. So we stop. We run again. And it also persisted the time. So at this point, all our CRUD functions work. Create works, read works, update works, delete works, right? So before we take a break for the first session here, I want to convert this to a generic. Because at this point, we've done maybe 4 different objects or 4 different labs with persistence, correct? We started off with, which one was the first one? Some persistence. But we've changed, we haven't touched the file manager extension. That's the same, that doesn't change, right? But here in our persistence helper, we come here, every time we have a new project, we have to change this to whatever the thing is. So currently we're working on photo journal. So we gotta come here, we gotta do photo journal, right? Or journal, whatever I called my object. That's not what we want to do. As developers, as Swift developers, we got exposed to generics 2 weeks ago. So why not use generics here, right? So let's use generics to convert our persistence helper class to a generic. It could work with any type. Everybody, right? When I say generic, it could work with any type, right? If I want to work with a photo journal, I don't have to change that class. If I have to work with an event, I do not have to change that class. So let us convert it to a generic. Everybody with me? Any questions about generics or what generics are?
I have a question about units, but I noticed that for the app, it only after you press like enter does it.
Make sure your keyboard is
I mean, even without the keyboard, it's only after you press enter that the updates. Like, what if the user doesn't press enter? Isn't it
when you say update, I don't understand.
It's only after you press enter and then press the update event.
You mean like here? Like when I'm in here?
Yeah, if you change the text.
And you just want to dismiss the thing?
Just naturally, like on an actual.
I mean, we could do it that way. We could add more code and make that work that way. But initially, when we created our app, we had to click return to add it. But now you could say when the user, when view dismisses, just call save or whatever. Okay? Like view will disappear, for example. There's a view will disappear lifecycle. When that's happening, you could just say save the data.
Okay.
Does that make sense?
Yeah.
So if you want to implement that, which we won't do right now, but if you want to implement that, you could go to your create event and your view life cycles. To review view life cycles, view did load gets called once, correct? Right? So this gets called once on initialized on initial load of view controller. Right? We have view will appear. Super view will appear. When does that get called? Every time the view controller is on screen. Very good. So every time view controller is on screen. Okay? We also have a view will disappear. When does this get called? Every time you exit the view. Right? So every time you leave that view, so you exit the view. So here you could call your save function. To persist data. Cool? Tiffany? Okay, so that's where you could put it. Cool? So as a user exits, it just says whatever the state of the screen is. Yes, and that's it. Cool? Very good. Let's keep up to date with our view life cycles. And as I said earlier, if you wanted to just always reload your table view, which is not the best practice, you would do it in your view will appear. Because view will appear every time you come back to that view controller, it gets called. Okay? All right, awesome. Thanks for the questions there. So let's go back to converting this guy to a generic. Okay, any questions about generics and what they are? Jahid, what's a generic? Right, so you could use any type, and not get mistaken with any, type any, because type any really, any, right? A mix, it could be heterogeneous. But generics, if you start with one type, you have to continue with that same type. So that's the power of generics. It keeps the language type safe, right? As opposed to any, if you say any is any. Like user defaults accepts any. Okay? Any questions about the two of them? All right, so let's go ahead and convert this. So what's the first thing? If I want to convert this to a generic, what's the first place I start? What do I do? Yeah, I'm in the persistence helper, data persistence. Conform to T. Well, you could say TU, whatever, right? So I start off by, as Sering is saying here, I start off by making my type. Remember, the type needs to be generic. So I start off by making the type a generic type. And as Sering says, you could use T here, convention, T for type. So I start off by saying data persistence is a generic of type T. Next, I say my array is also a generic type T. Okay? Keep going here. At this point, this guy is good, referencing instance. Okay, that's our first little hiccup here. It says referencing instance method in code on array requires that T conform to encodable. How do we fix that? Basically, I'm about to encode items. And items is a generic type. That generic type doesn't conform to anything, right? How do I fix that? Right now, I'm trying to use property list encoder, and remember, property list encoder only works on types that's codable or encodable in this case, right? It needs to be codable or encodable. How do we fix that? How do we make our type T restricted to only work with codable types? That's the next question. What's that? No, go ahead. I need to conform to codable. So my type T, thank you, Luber, my type T here needs to conform to codable. So now I've made my generic type constrained. This is called type constrained. So data persistence is now type constrained to only work with quotable types. Awesome. Any questions about that? That's very important here, especially as we go deeper into abstract data structures. Any questions about that? Because if it was a simple stack, like we did a stack before, we said stack is a generic type T. We were not doing any comparison, we were not doing any codable stuff, so that was fine. So if your type itself is not restricted to anything, but the minute you start saying, oh, I want my type to encode to some property list, the compiler says, hey, wait a minute. That's not acceptable because it's required that anything that says encodable or encode needs to conform to codable. So right away, you need to make your type T itself conform to codable. Everybody? All right. Yes?
Is this going to result in a data persistence class that can be used in any
That's the goal. That's the goal. Very good. So Chelsea reiterates our goal here. That data persistence, you could use it anywhere, right? On any object that you have. Yes, sir?
This is the update function you just wrote. Does it also have to conform to the code?
That's the next place we're going. Yes, sir. Very good. So Cameron is jumping ahead here. He's seeing that we just conformed our update function now needs to equate. It needs to equate its objects. So that too needs to conform to equatable. So let's go and we'll see where that error is and we'll also fix it. So let's keep going. Next error here is cannot invoke append here. Why? Oh, this guy needs to be T. That's good. Keep building as we go.
We can just change event wherever event is.
Yes, we can, but we should go through each function and see. Right? The Y is important, Tiffany. Yes, we could just do find and replace. Yes, totally. But now you know exactly what you're doing when you say event is now type T, right? Explicitly. And you keep building. This guy is type T. Awesome. Keep going. This one here is type T. Keep building. And here is Cameron's question, I think. Let's see. Incorrect argument label. Incorrect argument label. First index where type T here. Type T here. Okay, so when you change it to type T's, you come to Cameron's question about argument type T does not conform to expected type equatable. So this is Cameron's question. Now you have two type T's. You want to equate them. You want to find out if one is equal to the other, but you cannot. Because right here, you need to explicitly say type T conforms to equatable. So what do? We go back and we add equatable to our type T. Okay, everybody? So let's go up and do that. Let's go ahead and we could say and or an ampersand symbol here, equatable. Or we could also do like Swift does with quotable. That's exactly what Swift does with quotable. We could say type alias here. Type alias, give it some name, writable, and say quotable and equatable, and change this to writable. This is exactly what Swift does. So when Swift says something is quotable, This is what they're doing. They're doing line 19. They give it some alias name, quotable, and they say encodable and decodable. Everybody with me? Cool? So this is the same as when Swift says type alias, quotable. I'm not going to redefine the thing, but this is what it is. Encodable and decodable. Cool. So now our thing is writable, meaning it conforms to quotable and equatable. And you could give it any name that makes sense to you here. So writable is good. I'm sorry?
How many errors do you
1 second, I'm building right now. Yes. Oh, the writable, yes. Yeah. I have 4 more errors. Cool. Any questions about type alias before we move on? So we use type alias. When did we use type alias recently? A couple weeks ago?
We use it on string to.
Yes, we use it on string to change that array of strings to array of dog images. Everybody remember? Because we were using the dog API, it returned an array of strings, and we're like, hey, array of string doesn't really say what the thing is. So we gave string some alias of dog image URL. Very good. All right, so let's keep going. Next error.
Wait,
Yes.
wait, where's S4 now? And like, actually, just no, I'll see that.
Cannot convert type T to expected argument. Where are we? We TTT here. Build again. Build a bear. Where am I? Event. Oh, here I need to say as event here, because now I actually explicitly say what the thing is.
No, after the new item.
Where am I? New item, new item, new item. This guy here. Thank you, Chelsea. Next one is the same, right? Here, item. This guy should be type T. Event is. Oh, sorry. Sorry. 1 second. Okay, that was a bit. So our update, or what we did is change it to type T here, change it to type T here, and that's it. So just make sure that your update is similar to ours. Sorry for the confusion here. And at that point, we have 2 more errors somewhere.
For the persistent helper, we changed all of the events in the persistent helper to T.
Yes.
And then
There should be no event in this function anymore. So event here.
everything, there should be no more, no other word should be named event.
Exactly. So at this point, just do your thing earlier. Just search and replace. Because I think we are up to that point where we did. And we should have 0 event searches. 1 more error. Oh, that's an error someplace else. Yes, sir.
We're probably gonna get to it, but now there's errors on the schedule.
Yes, that would make sense. Okay, how are we doing with persistence helper or data persistence there? Are we good? Any more errors in that particular class? Yes.
I have a question. So we're working with one, like all of these are event for this particular one. But if we were to have more than one type that we're like dealing with, would we have to make another generic?
That's a good question for the guy who just left. Other reasons for having instances, I could have multiple instances of different persistence types. Like I could have a data persistence event, I could have a data persistence photo. Is that your question? Okay, go ahead.
No, like just because we're only dealing with event. Right?
For now, yes, in our app, but we could have other objects.
Okay.
The other objects, the question in the back there is we have errors in the view controller. Now you need to tell the persistence helper what type of object you're dealing with.
Would that be what we're doing?
Yes.
Okay.
That's where we would actually, remember back in our stack example with generics, we had to say a stack of what object with the angle bracket. Same as when you have a set, you say set, open angle bracket, string, close angle bracket. We need to specify what type we're dealing with. All right, so let's go do that. In our, any questions here? I'm hearing. Okay, we have 1 error, right? Let's fix the 1 error. Everybody, please copy the string here. Copy the string that says schedules.plist because we're using the same name. Not like it really matters. And let us refactor this data persistence initializer. Now our initializer is different. Actually, let me keep the initializer there and comment it out so we know where we came from and where we're going. So here we'll say public let data persistence equal to data persistence. And here we'll give it some type. We'll say event and some file name. We'll say schedules list. We build and we'll make sure we have no more errors. At that point, this syntax is very similar to a set we've seen before, right? So now we have a generic type data persistence of type event. And your event needs to conform to what? Well, not everything. What does the event, or what, like for example, your journal needs to conform to what? Quotable and equatable. Okay, that's it. Okay? So at that point, yes, you have a truly generic data persistence class that you could use in any project. So far, so good? So far, so good. Okay. You still have errors. Where's the errors? In the view controller or in the persistence helper class? You should only have one error in the view controller.
Did we add something else besides that?
No. You should only have one error in the view controller. Right at line 18, 19. Oh, sorry. Yes. I gotta do the 90-degree thing. Sorry. More.
Just a shout out examples. But for event, what if we put T there instead?
T doesn't mean anything. T is not a type. T in our class, good question. T signifies a placeholder. In our persistence helper class here, T, the type T here, T specifies, or T is a placeholder for the passed in type.
Okay, so, sorry.
Does that make sense?
Yeah.
Okay.
In the schedule list controller, where we have the data persistence is equal to what? Data persistence.
That answers your question, right, Brendan?
Yes.
Right.
Then,
At compile time, the compiler needs to know what T is. So you need to tell the compiler on line 19, T will be an event. And when the compiler runs, it replaces everywhere T is with that event.
What was the company instruction? T is just a placeholder?
Yeah, it's just a placeholder.
and the other time when we downcast the T, we force down.
Wait. We did not. Wait. You're talking about update here?
It says as,
Yes, Eric, sorry.
Alright, so, I see that we have to make T, which is code and equation.
Yes.
Why do we have to, if it's still forcing us to make, well,
No,
the event is already right, technically, right, because it's code and equation.
Yeah.
Why do we have to,
Well, event, why do we have to, sorry.
why do we have to tell it that T is as well?
We started off with just rewriting our persistence helper class, correct? We had nothing to do with event at that point, right? But as we went, we did the update. Update was the first place we had to make T conform to equatable. That's one. And the next place was when we did property list encoder. So at that point, our class itself, if it's a generic, it needs to conform to those two types, right? And type T at this point is constrained to quotable and equatable.
So if it wasn't,
If event, let's go to it. So if event here is only quotable, for example, right? That'll give us a compiler error.
so we have to make sure that the generic and the one that we cast to within the class
Yes,
are both
exactly.
conform to everything.
Exactly. More importantly, your type needs to conform to whatever the T is. Okay? Cool? Very good. Everybody got Eric's question here? Right? So we start off with the class data persistence. It has two constraint restrictions. One is quotable, second is equatable. Your journal, for example, needs to also conform to quotable and equatable. Not just quotable. It won't work. It's going to give you a compiler error. Good question. Build again, make sure we have no errors. And before we go to a break, let's do one more thing. Let's see. What's the twist on that one? Okay. Let's do one more thing here. Do we all have our code pushed to GitHub? Go ahead and push your code to GitHub. I'll wait on us. Go ahead and push our code to GitHub. I want to show us how to create a branch. Because we'll create a branch and we'll delete our data persistence files and we'll use the Swift package manager. But I want us to create a branch and then we'll see what that looks like. So first push your code up to GitHub. Yes. Yeah, coming right now. Okay, how are we doing? We pushed it? What is the error? We're not doing any networks in that app. Is that pushing to GitHub? Is it down or something? Double check to see if your Wi-Fi is working. Oh, yeah, you cannot push to mine. You're unauthorized. Delete your Git. Delete your Git. Let me show you one thing. Let's pay attention here. If you clone your project, you need to delete the Git history. Follow along here. I'll show us how to do it. Okay, so I'll navigate over to, everybody use terminal for this. I know we could do it in Xcode, but I don't want us to cling to Xcode too much with like Git history. I want us to be able to go back and forth between Xcode and terminal when it comes to Git. Everybody, please, please, please keep that in mind there, because terminal at the end of the day is more powerful, right? Xcode gives us some nice UI, some nice things to do, but we really have to still know our Git commands, yes? Okay, so everybody navigate to your project in GitHub. I mean, in terminal, navigate to your project. Scheduler. Okay, so if you are okay pushing your project to GitHub, that step does not apply to you. But if you cloned your project, from GitHub, you want to delete the .git directory. So if you do an ls-a, again, if your Git is working correctly, do not do this step, okay? But I think only Luba, right, Luba? She cloned earlier from my repository. She cannot push to my repository. So if you're able to push to your repository, skip this step. Do not do this step. Okay? But if you need to remove the Git, this is the command here. So you type in rm-git and press enter.
When I'm in.
You have to be inside your scheduler app. You inside your scheduler app and you did ls-a, correct? And you see a .git there, correct? So do rm.git. It removes the Git folder. Press enter and do an ls-a again. You removed it. You never had it. Did you push successfully earlier?
It removed it now. Oh, no, I didn't.
Okay.
I had the same issue.
Still there.
It's RF already. Sorry.
Alex, isn't there a different link for graphics?
It's RF. One second.
Sorry, you need to recursively move all the folders. So you need to do -rf. Sorry about that. So rm-rf here, .git. Okay?
Now I do.
And now go back to Xcode and push through Xcode.
I can't push.
No, you need to get the remote repository. It's easier to just do it through Xcode at that point.
Commit and push.
Yes. Okay. So, what are we doing here? We are trying to create a branch. Let's go ahead and type in clear here. Type in get branch -a. That's inside the scheduler folder. Luba, I'll work with you after the break. Get you up to speed there. So everybody who has a Git history, type in get branch -a. That lists all your branches, remote and local. What is a branch? A branch, basically, we start off, if you create a project, you have one branch. You have a master branch. Everybody has a master branch by default.
You have to include that symbol as well?
Which, no symbol, just get command branch -a. As we talk about those commands, write it into your notes somewhere so you know what the commands are. So get branch -a is list all branches. List all branches. List all branches. Okay? That's what that command is. Okay. If we see my terminal, we see a green and we see an asterisk. We see that? On your terminal, you see that as well, correct? Master says where you currently are. I'm currently on the master branch because I only have one branch. Yes, I only have one branch. So the objective is to create a second branch, right? The second branch will have everything that master has, all the code we've pushed so far. Actually, let's go ahead and make sure you push all your code. Thanks for talking out loud here. Let's do get status here. So we have code, we changed a lot of things. So do get status, and then do get add everything. Get status, get add everything, and get commit. What did we do today? We persisted updates. Persisted event updates. Okay? And added generic. Okay, this is what we did today. So I wrote a commit message, a bit longer than I would like here, but that's fine for now. So get commit, enter. And what's the next command? Get push. Awesome. So before you go ahead and you check out a different branch or a new branch, make sure you push all your updates. So at this point, I've pushed all my updates. If I say get status, make sure it says nothing to commit. When you say get status, make sure it says there's nothing to commit. Let's clear my console here. Next step, I want to create a new branch. What is my objective of creating a new branch? It could be many things. It could be I want to test a new feature in my app. It could be experimenting on something. In our case today, I want to create a new branch because I want to include a Swift package manager and delete my data persistence files, right? So when I go back to my code, I want to see one branch that has my data persistence files, right, which we did today in class. And the second branch will use the Swift package data persistence package, right? So those are two different things. So if you want to experiment with something new, you could create a branch. You're working on a group project, which will start in 2 weeks. Everybody will have some feature they work on. Somebody's working on login. Somebody's working on, well, the app is going to be New York Times Books app. Somebody's probably working on the favorites controller. Somebody's probably working on the main books list controller. Everybody's working on a different feature of the app. They work on a different branch. When they're ready to merge their code, they merge it back to master or production, whatever it is. A branch, you start a new project, you say get commit, you say get init, get push. You have a default branch. What's that default branch called? Master. Anytime you want to do all the work, or the features, whatever it is, you create a new branch. You go work on that thing. When you're done, you go back and you merge into master. Yes? We won't do merging today, but we'll just introduce branching today. So assuming you have a tree, our tree right now has one branch. We will create a second branch for that tree, and we'll name it data persistence package manager or something like that, and we'll go off there, and we'll do the work we want there in that code, right? So same commits, it will have the same commits, including its own commits. Everybody with me? So if we branched off, how many commits do we have here? Get log. 2 commits. So right now we have 2 commits. When I branch off, get log, by the way, shows the commits. So go ahead and get log, it shows your commits. Clear. If I do get log here, it shows my commits. It shows all the commits. So if you have more commits, you could just press enter, it will show you the commits, all the commits history. But currently we only have 2 commits, so that's great. But if you have more commits, you have to start scrolling down, Tiffany, to show all the commits or whatever commit you want to get to. So the first commit I had was initial commit, which was Thursday, yesterday. And my second commit is today, Friday. It shows the 2 commits I have. So when I create a new branch, the new branch will have how many commits? 2. The new branch will also have the commits that master has, right? Remember, if I'm branching off, the terminology is I'm branching off master. I'm creating a branch off of master. So if I create a branch off of a next branch, it also takes all the commits of that branch that it's branching from. Okay?
Does that include new commits to the master branch?
We get push everything, right? We get push everything.
Is it just everything up to date?
Everything up to date, yes. Very good. So when I say get create new branch, it will have those 2 commits as well. Okay. So we saw a new command. The new command was get branch -a. It lists all the branches. We also saw get log. It lists your commits. Now let's see creating a branch. Let me clear the console. So creating a new branch, it's get the branch name, actually branch, sorry. And the branch name, we will call it data persistence, data persistence SPM, or rather including data persistence package, Swift package. Get branch including data persistence package. So this is creating a new branch. Creating a new branch, git branch and the name of the new branch. Okay? At that point, I'll press enter. Are we all typed out here? Yes? Yes? Can I continue? Okay, so I'll press enter. I'll do get branch. Now, when I did get branch, see what we have. We have 2 branches now, right? The next step is, if you want to go to that branch you just created, get, check out, the name of the branch. Tab. I gotta work on tab here. Persistence package.
You have to write out everything?
I will introduce you to a way to quickly tab over here. But yes, check out the name of the branch, the place you're going. And press enter. I think that's what Christian just did, right? You did switch to branch. So now if you do get branch to see what branch you're on, get branch allows you to know what branch you're on. Here, now it should say green with the included data persistence branch. Everybody with me? Everybody with me? Okay, perfect. Now let's go back to Xcode here. Go back to Xcode. If all went correctly, we should be able to see, go back to Xcode and go to your source navigator. Click on branches. If all went well, you should see the branch that you're currently on is including data persistence package. Do we see that? Right? So now we have 2 branches. We have a master branch and we have the including data persistence package branch. And keep in mind, everything we just did in terminal, we could do it in Xcode. But I wanted to show it to us in terminal. Right here in Xcode, I could say, let's go here, click on master. I could say check out master. Everybody? So here I could check out branches in Xcode. If I want to go back to master, I could do it via Xcode. Okay? Back and forth. All right, so what do we want to do here before our break? Let's go to our, so right now, our master is good. We could do anything we want with this particular branch. I could break code, I could test code, I don't really care. Because I know my master is like a backup. Think about it like a backup. So anytime you want to start investigating new things in your code, create a branch, go experiment, break things. It works, great. It doesn't work, there's no tears. Okay? All right, so now what we want to do, we want to delete this data persistence folder. Right? So right click on the data persistence folder, delete it, delete, move to trash, right? Build, and we'll have errors. Makes sense. What are the errors here? Unresolved data persistence, doesn't know about it. Right?
How do we know that we're on the second?
We just showed it earlier.
No, I know it says it.
Current, it shows current. You see current here? Do you see current? Click on the source navigator, open up the branches folder. You'll see 2 branches, and it will show you the current one you're on in parents.
You have to click on it for it to say that?
This is going to be closed. The branches folder will be closed. You open it up, and then, cool? All right, awesome. So next step, what do we want to do? Right now, we just broke our code. We have no data persistence, correct? Let's add a data persistence. So let's navigate over. Why don't I have a browser open? Yes. Delete the entire folder. Yes. Just click on the folder itself and delete, move to trash. And what do we need now? We need a data persistence. So we'll use this one. Team. This is not.
Is there an easier way to save the links or injections?
That's a good question. Okay, so I slacked over. I'll come back to that. See what's the easiest way there. For me, I just type it out because I just know where the thing is. But let's see. Let's go back to Xcode and let's add a Swift package, right? So this link I just sent out to us, copy that URL. Everybody. Copy the URL that I just sent out into Slack. This is the URL here. Copy the URL, right? This is our Swift package manager. I need to update this a little bit just to show more use cases here. But this is our data persistence model. We'll go back to Xcode and we'll add a Swift package. We go to File. We go to Swift Packages, Add Package Dependency, and we paste in the URL. And we click on Next. And we keep version rules checked, right? We'll go with versions. The current version should be 1.1, correct? Is that what we see? And we click Next. It resolves. And we click Finish. It installs it. Now we have our data persistence library. We could go back to where we need it. We build, Command B. Let's go back to our errors here. So we have an error here. It doesn't know about data persistence. So we import data persistence. Build. Look at that. Just one error. Beautiful. So we run our app again. Let's see if it still works. I still have my lab photo, or my lab photo. If I add some random event, create, stop, run again, still there. If I delete it, stop, run again, still works. Cool? So, yes?
I still have a very
Do you run it? Just run it. Because sometimes Xcode takes a while to. All right, I'll check it like right now while when we're on break. I'm sorry, say that again. Could not create a new event? Anybody cannot create a new event? Were we able to create events? Sering? Christian? David, were you able to create an event? Anybody else not able to create an event? Eric, were you able to create? Delete? Okay, so cool. So we have confirmation, it works. So what we just did now, we created our data persistence model. We know it works. Now we created a branch. We removed our data persistence and we added it via Swift Package Manager. So now we have two branches. Actually, let's go ahead and push our code to GitHub. Go back to terminal and do get status here. So do get status in terminal. We see things modified. The project folder got modified. Our schedule list got modified because we added the import data persistence there. And now we have a package as well. So we want to push all those to GitHub. You want to include your package as well. So let's just go ahead and git add everything here. Git add, git commit. Yeah, that's on the current branch. Currently, we are, good question. Let's see what branch we're on. So we're still on the included, including data persistence package branch, okay? So we did git add, get commit. The commit message, we could simply say added data persistence package. And get push. We don't have a remote yet, so simply copy that string here to add the remote. You should see get push set upstream. You need to create that remote branch. So copy the string here. Press enter. And to verify that we do have 2 branches, we'll go to GitHub and we'll see now we have 2 branches. So let's go to GitHub. Go to GitHub here. Go to my repositories.
You just copy and.
Yeah, just copy the string, paste it in, and press enter. Very good. So if we navigate over to our GitHub page with our repo, we should see 2 branches. Do we see 2 branches? Right? So we should see 2 branches. If I click on my 2 branches, I see master branch, which is the default branch. You could also change what that is. And the current branch we just added. Okay? And we could navigate around. Not every time you have to get close. If you want to see a folder, you navigate around here. Right? So let's go here, navigate around here. I could go inside my scheduler. And my scheduler, on the master branch, my scheduler still has the data persistence files in the folder, remember? So the 2 branches, what's the difference? One has the data persistence folder. The second branch does not. The second branch uses the Swift package manager. Everybody? A mini question? Okay, cool. Any questions before we wrap up?
Can you go back to terminal?
Go back to terminal. Questions about terminal?
What did you have to git commit?
Get commit, we did get push, and then we needed to add the remote. So you needed to copy this line string. And then you paste it in, and it creates a remote branch, and it pushes it at the same time.
So how does everything come together when people are pushing different branches?
When you're ready to merge, we're not going to show merging today, but when you're ready to merge, like for example, if you're working on feature A, somebody's working on feature B, then when you're ready to merge, you merge it back to some master branch or production branch.
Okay, so
In our case, you'd merge it back to master.
Okay, so technically speaking, there should be three levels of branching.
It depends on how many people on the team. If there's 3 people on the team, there's 1 production or 1 master branch, and there's 3 other branches where you each working on that feature. Right? So you work on feature X, it's ready, you merge it into master, you go back and work on feature Y. Cool? All right, but today we only introduced branching and we only introduced pushing to a different branch. That's it. Cool? Good? Any questions before we end here? So to reiterate what we did here, we updated an event, we persisted the update, and we did a bonus here. We created a new branch. Right? We created a new branch to include the Swift package manager or the Swift package data dependency, and we removed the data persistence folder. Okay? To really show us like what branching is, because branching is really coming up very soon. So we need to start getting exposed to branching. And as I'll always say, practice it yourself, work on some project, and branch off the project and see what it does. Okay? And even try merging. Try merging. Try merging. If you have questions, you can come to us about that. Okay? All right. So we'll break. We'll come back. We'll come back at 11:45, and we'll talk about subclassing UI tab bar controller. And we'll stop at 12:30, and we'll have demos. Cool? Thank you.